This video is practice verifying trig identities. So here is a basic equation setup, and we need to use our trig values to help us make sure or verify that the left side is equal to the right side. There are 5 examples in this video, so feel free to fast forward if you need to. So we're going to look at example 1. I have cotangent and cosecant, and I want it to turn into just a cosine. So what I need to do is use what I know about cotangent and cosecant in my notes page. So cotangent is cosine over sine. And our goal is to put things in terms of cosine and sine. That way we know what we can reduce. So cotangent is cosine over sine. So I'm going to keep it on the top of the fraction, and I'm going to put cosine over sine. And then the bottom of my fraction is cosecant x. And cosecant is 1 over sine. And my goal is to verify, can I get this equal to cosine of x? So I cannot divide by a fraction. I'm going to need to multiply by the reciprocal. So I'm going to set up the top part as a basic fraction. So I'm going to put cosine x over sine x. And instead of dividing by a fraction, we multiply by its reciprocal. So instead of 1 being on the top, we're going to put 1 on the bottom, and then sine x will be on the top. We want to verify if this will equal cosine of x. Now I'm looking for things that I can reduce. I have a sine on the bottom and a sine on the top. This will reduce out to 1. That leaves me with cosine on the top and 1 on the bottom. I do not need to put the 1 on the bottom. I can just leave this as cosine x and cosine x. I have verified that I can simplify this so that both sides equal cosine x. I'm going to move on to example 2. Example 2 looks a bit more complicated. Notice in example 2, I have a squared sign. That just means there are 2 cosines. So we're going to start on the far left. Our goal is to simplify the left and verify that it equals the right side. I'm going to put everything in terms of sine and cosine. So starting with tangent is sine over cosine. So we're going to make this sine x over cosine x. And then multiply by cosecant. If I come over to my notes page, cosecant is 1 over sine. Now, cosine squared just means there are 2 of them. So we're going to go cosine x is equal to cosine x. At least we're hoping it will. So now let's go through and see if I can simplify anything. I see a sine on the top and a sine on the bottom, so that reduces out to 1. Again, I have a cosine on the top and a cosine on the bottom. That'll reduce out. Now let's look at what's left over. I have a 1 on the top and a cosine at the top of a fraction. So 1 times cosine is just cosine, so I'm going to put cosine x. That's the only thing I have left over, is equal to cosine x. I have verified that I can simplify the left and have it equal the right. We're going to move on to example 3. In example 3, notice I have another fraction equal to sine x. So we're going to put everything in terms of cosine and sine. The top of my fraction is just cosine. There's nothing there to transform. All over cotangent. I'm going to put that in terms of cosine and sine. If I look at my notes page, cotangent is cosine over sine. So we're going to make this a nice big fraction, cosine over sine. We want to verify if we can get it equal to sine x. Again, we do not want to divide by a fraction. So we're going to multiply by its reciprocal. So let's look at the very top one. It's just cosine x. Again, this is if I went over 1. Now, instead of dividing, we're going to multiply by the reciprocal. Cosine x is on the top of this fraction. Reciprocal would make it go down. Sine x is on the bottom, but using the reciprocal, it would bring it to the top. Let's see if there's anything we can reduce. I have a cosine on the numerator and a cosine in the denominator. I can reduce that to 1. Sine over 1 is just sine, so I'm going to put sine of x is equal to sine of x. I have verified I can get the left and the right to match. We're going to move on to example number 4. Example number 4 has a secant and a cotangent. I'm going to transform my left side into cosines and sines. Secant, using my notes page, is 1 over cosine. Cotangent, using my notes page, is cosine over sine. Let's see if anything will reduce. I see a cosine on the bottom and a cosine on the top. I can reduce that to 1. I have a 1 on the top and a sine on the bottom. 1 on the top, sine on the bottom. Now our goal is to make sure that the left and the right are matching. So let's go see what 1 over sine is. Coming over to my notes, 1 over sine is cosecant. So I'm going to rewrite this as cosecant x. Cosecant x. I have verified I can get the left and the right to match. Example 5 is the last example. We have cosecant and tangent. We're going to transform these into cosines and sines. Looking at cosecant on the notes page, I end up with 1 over sine. If I look up tangent on the notes page, that's sine over cosine. Our goal is secant. Let's look to see if there's anything I can reduce. I have a sine on the bottom and a sine on the top. I can reduce that to 1. I am left over with a 1 on the top and a cosine on the bottom. Our goal is that the left and the right side match, so I'm going to go look up 1 over cosine on the notes page. 1 over cosine is secant. Rewriting this with secant, I now have the left and the right matching.